Welcome back, guys. In this video, we are going to start with class B and class C. So let us begin. Okay, first of all, starting with class B. In class B, so whatever the 32 bits address size that we have for IPv4 protocol, we are going to split that particular address space into the first byte, second byte, and the 4 bytes. So what class B says that it says that the first 2 bits, the leftmost 2 bits, will be restricted to 1 and 0, and the rest of the bits can vary. So if I have restricted the first 2 bits like 1 and 0, then the total number of IP addresses that are possible in class B is actually equivalent to so there are 32 bits, and out of those 32 bits I have restricted 2 bits, like which are restricted to 1 and 0. So I, for rest of the 30 bits, I can have any combination and any possible combination of zeros and one. For those zeros and ones, I can write that the total number of IP addresses that are possible in class B is actually equivalent to 2 to the power 30, and it is also equal to 25% of the IP of the address space of IPv4 of address space. Okay, now moving on, how do we identify, like if I have been given an IP address, and how do I identify that that IP address belongs to class B or not? For the identification purpose, like I told you, for if we have the binary representation of IP address, then we can simply say that if we look at the leftmost 2 bits, then we can, if it is 1 0, then we can easily say that it belongs to class B. But what if we have the dotted decimal representation of IP address? But for the dotted decimal representation, like I told you, we are going to just only check the first byte for every IP address, and on the basis of the first byte we can easily identify whether that particular IP address belongs to which class. Okay, now moving on, like if we want to identify the first byte, so for identification of the first byte, like I told you, we are going to expand the first byte into the 8 bits, and the rest of the bytes are going to remain the same. So for checking the first byte, like I told, like in this way, the first leftmost 2 bits are restricted to 1 and 0, and the rest of the bits can, in the first byte, can be from zero, can have any combination of zeros and ones. So if I calculate like 0 0 0 0 to 0 0 0 1, and it can end up till 1 1 1 1 1 1 for rest of the 5 bits. So the total so the range of IP addresses for this, the decimal equivalent is actually equivalent to, so this number is that in decimal it's equivalent to 128, and for this number, this binary number, we have the decimal equivalent as 191. So for, if I talk about the range of IP addresses, like in this case, the first byte is restricted to 128 to 191 as per the class B methods. So it is from 128 to 191. But what about the rest of the bits, the rest of the bytes that we have? So as I told you earlier, that the rest of the bytes can have any combination of 0 to 255 for each of them. So it can, so the range of class B IP addresses will start from 128.0.0.0 to 191.255.255.255. So I hope that's clear. And moving on, so this is about the class B. Now moving on, we have another concept of network ID and host ID. So for class A, like I told you, like in the for class A, the first byte of the IP addresses is reserved for the network ID. For class B, it says that the first 2 bytes are actually reserved for the network ID. So this is first byte and this is the second byte, and both of the bytes are reserved for the network ID, and the rest of the bytes are reserved for the host ID. Okay, so moving on, so if I talk about the total number of networks that are possible in class B, then all I have to do is just check the number of bits that are available. So here the number of bits that are available is actually, so if I have 2 bytes, there are 16 bits, and out of those 16 bits, 2 are restricted, 2 are set to 1 and 0, so it will be minus 2 bits. So I have the total number of available bits that I have in network ID is 14 bits, and for all of those 14 bits, I can have any combination of 0 and 1, which is equivalent to 2 to the power 14, which is the total number of networks that I can have in class B. Total number of networks in class B. Okay, So that was about the networks that are possible in class B. Now if I talk about the total number of hosts that are possible in class B, for the host I can have any combination of zeros and ones for the rest of the 16 bits that are left. So for the rest of the 16 bits I can have any combination of 0 or 1. So the total number of hosts that are possible in each network, so that are corresponding to each network of class B, is actually 2 to the power 16. Okay, now out of those 2 to the power 16 hosts that are possible, like I told you, the first 000, for the first two bits, like the first 2 bytes for the host will be reserved for the first 00, that is the first host will, for each network, the first host will be reserved for first IP will be reserved for the network IP, and the last IP will be reserved for the direct broadcast IP, which is 255.255. For each network, the first IP and the last IP are reserved for network IP and the direct broadcast IP. Okay, so if we see like that, then the total number of available the usable hosts that I can use in each network of class B is actually 2 to the power 16 minus 2. Okay, so now moving on, default mask or network mask for class B. So like I told you, if you want to calculate the default mask or the network mask for any class, or what we have to do is just simply take the number of bits that are there in the network ID and set them to 1. So if I take the network ID, which is for class B, then the 2 bytes are corresponding to the network ID in class B. So if I put all the ones in the network ID for class B, then it will be equivalent to 255.255.0.0. Okay, so that was all for class B. Moving on, we are also going to cover class C as well in this module, in this particular video. So in class C, like in class B, what we do is we restrict the first leftmost 3 bits to 1, 1 and 0, and the rest of the bits can vary similarly. So if I talk about the total number of IP addresses that are possible in class C is actually, so the total number of bits is 32, and I have restricted 3 of them. So I'm left with 29 bits. So if I can vary all of the 29 bits, then the total number of IP addresses that are possible is 2 to the power 29, which is which is also equal to 12.5% of total address space. Okay, now moving on, how do we identify whether an IP address belongs to class C or not? For identification, we have two notations. We are going to discuss two notations. The binary notation is very simple. I hope that it's clear and it's pretty much self-explanatory. Now moving on, for the dotted decimal part, what we do is, like I told you, we are only going to check the first byte. For the first byte, so for the first byte, we have fixed the first 3 bits, and the rest of the bits can vary from any possible combination of zeros and ones. So if I write the decimal equivalent, then it is the decimal equivalent for this number, which is equal to 192, and for this number it is equal to 223, and the rest of the 3 bytes can vary from for each network, for each of these combinations. The rest of the bytes can be from 000 to 111. So if I write the range of the IP address for class C, it's actually class C. Okay, so the range of IP addresses for class C is actually from 192 to 223. Okay, and the rest of the things, rest of the bytes, it will be remain same. Like it can be from 000 till 255.255.255. So I hope that was clear. Okay, now moving on. So that was all for class C. So if I want to talk about the network ID and host ID for class C, so in class C, what we have is that the first 3 bytes are reserved for the network ID and the last byte is reserved for the host ID. So if I have the first 3 bytes, so the first 3 bytes are composed of 24 bits. So the total number of networks that are possible in class C is actually 24 bits, and the first 3 bits are reserved. So it is equivalent to 2 to the power. So we have total 21 bits, and if we can in those 21 bits we can have any combination of 0 or 1. So there are 2 to the power 21 networks that are possible in class C. For each network, now we have to calculate for each network how many hosts are possible. For each network, the number of hosts that are possible for each network is equal to the rest of the bits, which are 8 bits, and for 8 bits I can have any combination of 0 and 1. So the total number of hosts that are possible in each network of class C is actually 2 to the power 8. Okay, now like I explained in the previous part of class B and class A as well, like the first IP for each network is reserved for the network IP, which is the first IP, and the first IP is actually 0, uh, and the last IP for each network is reserved for the direct broadcast address. So this is for network IP, and this is for direct broadcast IP. Okay, so if I say the number of usable hosts that are present in each network of class C, then it is equivalent to 2 to the power 8 minus 2. So I hope that was also clear. Now moving on, we want to calculate what is the default mask for network mask for class C. So as I told you, what we have to do is we have to simply put all the ones for the network ID part, and just then we'll have our default mask or the network mask for that particular class. So if I put all the ones for all the bits that are there in the network ID part, then it will be 255.255.255.0. So that will be the default or the network mask for class C. So that will be all for this video, guys. Thank you so much for watching. In the next video we are going to cover about class D and class E. So thank you.